The Boeing 777 is a family of long-range wide-body twin-engine jet airliners developed and manufactured by Boeing Commercial Airplanes. It is the world's largest twin jet and has a typical seating capacity for 314 to 451 passengers, with a range of 5,235 to 9,500 nautical miles, 9,695 to 17,594 kilometers. Commonly referred to as the 777, its distinguishing features include the largest diameter turbofan engines of any aircraft, 6 wheels on each main landing gear, fully circular fuselage cross-section, and a blade-shaped tail cone. As Boeing's first flight-by-wire airliner, it has computer-mediated controls. It was also the first commercial aircraft to be designed entirely with computer-aided design. The 777 is produced into fuselage lengths as of 2014. The stretched 777-300, which is 33.25 feet 10.1 meters longer, followed in 1998. The earlier 777-200ER and -300 versions are equipped with G90, Pratt and Whitney PW4000, or Rolls-Royce Trent 800 engines. The 777-200LR is the world's longest-range airliner, able to fly more than halfway around the globe, and holds the record for the longest distance flown non-stop by a commercial aircraft. The 777 first entered commercial service with United Airlines on June 7, 1995. The most common and successful variant is the 777-300ER with 665 delivered and 800 orders. Emirates operates the largest 777 fleet, with 144 passenger and freighter aircraft as of July 2015. The 777 has been involved in 6 hull losses as of August 2016. The Asian Airlines Flight 214 accident in July 2013 was its first fatal crash in 18 years of service. The 777 ranks as one of Boeing's best-selling models. Direct market competitors include the Airbus A330-300, newly launched Airbus A350XWB, and the out-of-production A340 and McDonnell Douglas MD-11. The 787 Dreamliner, which entered service in 2011, shares design features with the 777. In November 2013, Boeing announced the development of upgraded 777-8 and 777-9 variants, collectively named 777X, featuring composite wings and G9X engines and further technologies developed for the 787. Background: in the early 1970s, the Boeing 747, McDonnell Douglas DC-10, and the Lockheed L-1011 TriStar became the first generation of wide-body passenger airliners to enter service. In 1978, Boeing unveiled 3 new models: the twin-engine Boeing 757 to replace its venerable 727, the twin-engine 767 to challenge the Airbus A300, and a tri-jet 777 concept to compete with the DC-10 and L-1011. The mid-size 757 and 767 launched to market success, due in part to 1980's Extended-Range Twin-Engine Operational Performance Standards (ETOPS) regulations governing transoceanic twin jet operations. Under ETOPS rules, airlines began operating the 767 on long-distance overseas routes that did not require the capacity of larger airliners. The trigid 777 was later dropped, following the marketing studies that favored the 757 and 767 variants. Boeing was left with a size and range gap in its product line between the 767-300ER and the 747-400. McDonnell Douglas was working on the MD-11, a stretched and upgraded successor of the DC-10, while Airbus was developing their A330 and A340. In 1986, Boeing unveiled proposals for an enlarged 767, tentatively named 767X, to target the replacement market for first-generation wide-bodies like the DC-10, and to complement existing 767 and 747 models in the company lineup. The initial proposal featured a longer fuselage and larger wings than the existing 767, along with winglets. Later plans expanded the fuselage cross-section but retained the existing 767 flight deck, nose, and other elements. Airline customers were unimpressed with the 767X proposals, and instead wanted an even wider fuselage cross-section, fully flexible interior configurations, short to intercontinental range capability, and an operating cost lower than any 767 stretch. Airline planners' requirements for larger aircraft had become increasingly specific, adding to the heightened competition among aircraft manufacturers. By 1988, Boeing realized that the only answer was a new design, which became the 777 twin jet. The company opted for the twin-engine configuration given past design successes, projected engine developments, and reduced cost benefits. On December 8, 1989, Boeing began issuing offers to airlines for the 777 design effort. The design phase for the new twin jet was different from Boeing's previous commercial jetliners. For the first time, 8 major airlines, all Nippon Airways, American Airlines, British Airways, Cathay Pacific, Delta Airlines, Japan Airlines, Qantas, and United Airlines had a role in the development. This was a departure from industry practice, where manufacturers typically designed aircraft with minimal customer input. The 8 airlines that contributed to the design process became known within Boeing as the Working Together Group. At the first group meeting in January 1990, a 23-page questionnaire was distributed to the airlines, asking what each wanted in the design. By March 1990, Boeing and the airlines had decided upon a basic design configuration: the cabin cross-section close to the 747's, capacity up to 325 passengers, flexible interiors, the glass cockpit, fly-by-wire controls, and 10% better seat mile costs than the A330 and MD-11. Boeing selected its Everett factory in Washington, home of 747 production, as the 777's final assembly site. On October 14, 1990, United Airlines became the 777's launch customer when it placed an order for 34 Pratt & Whitney-powered aircraft valued at $11 billion with options on an additional 34. The development phase coincided with United's replacement program for its aging DC-10s. United required that the new aircraft be capable of flying 3 different routes: Chicago to Hawaii, Chicago to Europe, and non-stop from Denver, the hot and high airport, to Hawaii. ETOP's certification was also a priority for United, given the over-water portion of United's Hawaii routes. In January 1993, the team of United developers joined other airline teams and Boeing designers at the Everett factory. The 240 design teams, with up to 40 members each, addressed almost 1,500 design issues with individual aircraft components. The fuselage diameter was increased to suit Cathay Pacific, the baseline model grew longer for all Nippon Airways, and British Airways. Input led to added built-in testing and interior flexibility, along with higher operating weight options. The 777 was the first commercial aircraft designed entirely by computer. Each design drawing was created on a 3-dimensional CAD software system known as CAD-i8, sourced from Dassault Systems and IBM. This lets engineers assemble a virtual aircraft, in simulation, to check for interference and verify that the thousands of parts fit properly, thus reducing costly rework. Boeing developed their own high-performance visualization system, FlightRoute, later called ID, the Integrated Visualization Tool, to support large-scale collaborative engineering design reviews, production illustrations, and other uses of CAD data outside of engineering. Boeing was initially not convinced of CAD-i8's abilities and built a physical mock-up of the nose section to verify its results. The test was so successful that additional mock UPS were cancelled. Production and testing. The production process included substantial international content, an unprecedented level of global subcontracting for a Boeing jetliner, later exceeded by the 787. International contributors included Mitsubishi Heavy Industries and Kawasaki Heavy Industries fuselage panels, Fuji Heavy Industries, Limited Center Wing Section, Hartford de Havilland Elevators, and Aerospace Technologies of Australia Rudder. An agreement between Boeing and the Japan Aircraft Development Corporation, representing Japanese aerospace contractors, made the latter risk-sharing partners for 20% of the entire development program. The initial 777-200 model was launched with propulsion options from 3 manufacturers: General Electric, Pratt & Whitney, and Rolls-Royce, giving the airlines their choice of engines from competing firms. Each manufacturer agreed to develop an engine in the 77,000 lbf 340 kN and higher thrust class, the measure of jet engine output for the world's largest twin jet. To accommodate production of its new airliner, Boeing doubled the size of the Everett factory at a cost of nearly $1.5 billion to provide space for 2 new assembly lines. New production methodologies were developed, including upturned machine that could rotate fuselage sub-assemblies 180 degrees, giving workers access to upper body sections. Major assembly of the first aircraft began on January 4, 1993. By the start of production, the program had amassed 118 firm orders, with options for 95 more from 10 airlines. Total investment in the program was estimated at over $4 billion from Boeing, with an additional $2 billion from suppliers. On April 9, 1994, the first 777, flying number WA001, was rolled out in a series of 15 ceremonies held during the day to accommodate the 100,000th invited guests. The first flight took place on June 12, 1994, under the command of Chief Test Pilot John E. Cashman. This marked the start of an 11-month flight test program that was more extensive than testing for any previous Boeing model. 9 aircraft fitted with General Electric, Pratt & Whitney, and Rolls-Royce engines were flight tested at locations ranging from the desert airfield at Edwards Air Force Base in California to frigid conditions in Alaska, mainly Fairbanks International Airport. To satisfy ETOP's requirements, 8 180-minute single-engine test flights were performed. The first aircraft built was used by Boeing's non-destructive testing campaign from 1994 to 1996, and provided data for the 200ER and -300 programs. 54 At the successful conclusion of flight testing, the 777 was awarded simultaneous airworthiness certification by the U.S. Federal Aviation Administration (FAA) and European Joint Aviation Authorities (JAA) on April 19, 1995. Interior: the original 777 interior, also known as the Boeing Signature Interior, features curved paddles, larger overhead bins, and indirect lighting. Seating options range from 6 apift in first class up to 10 across in economy. The 777's windows were the largest of any current commercial airliner until the 787, and measured 15-inch 380mm by 10-inch 250mm in size. All models outside the 777-8 and -9. The cabin also features flexibility zones, which entails deliberate placement of water, electrical, pneumatic, and other connection points throughout the interior space, allowing airlines to move seats, valleys, and lavatories quickly and more easily when adjusting cabin arrangements. Several aircraft have also been fitted with VIP interiors for non-airline use. Boeing designed a hydraulically damped toilet seat cover hinge that closes slowly. In 2003, Boeing introduced overhead crew rests as an option on the 777. Located above the main cabin and connected via staircases, the forward flight crew rest contains 2 seats and bunks, while the aft cabin crew rest features multiple bunks. The Signature Interior has since been adapted for other Boeing wide-body and narrow-body aircraft, including 737NG, 747-400, 757-300, and newer 767 models, including all 767-400ER models. The 747-8 and 767-400ER have also adopted the larger, more rounded windows of the original 777. In 2011, Flight International reported that Boeing is considering replacing the Signature Interior on the 777 with a new interior similar to that on the 787, as part of the move towards a common cabin experience across all Boeing platforms. With the launch of the 777X in 2013, Boeing confirmed that the aircraft would be receiving the new interior featuring 787 cabin elements and larger windows. Further details released in 2014 included re-sculpted cabin sidewalls for greater interior room, noise dampening technology, and higher cabin. The 777-300ER for extended range is the C markup version of the -300. Its higher MTOW and increased fuel capacity permits the maximum range of 7,370 nautical miles 13,650 kilometers with 396 passengers in a two-class seating arrangement. The 777-300ER features raked and extended wingtips, a strengthened fuselage and wings and a modified main landing gear. Its wings have an aspect ratio of 9:0. It is powered by the GE90 115V turbofan, the most powerful jet engine with a maximum thrust of 115,300 lb/f 513 N. Following the flight testing, aerodynamic refinements have reduced fuel burn by an additional 1.4%. Since its launch, the model has been a primary driver of the twin-jet sales past the rival A330/340 series. Its direct competitors have included the Airbus A340-600 and the A350-1000. Using two engines produces a typical operating cost advantage of around 8–9% for the 300ER over the A340-600. Several airlines have acquired the 300ER as a 747-400 replacement amid rising fuel prices given its 20% fuel burn advantage. The first 300ER was delivered to Air France on April 29, 2004. The 300ER is the best-selling 777 variant, having surpassed the 200ER in orders in 2010 and deliveries in 2013. As of July 2016, 300ER deliveries to 45 different customers totaled 665, with 135 unfilled orders. In February 2016, 619 300ER thus are in service with 35 operators.